Welcome to the first seminar of the Aggie Docs Computer Science Club, Python Basics. To accommodate for everyone's varying schedules, these seminars are recorded with the option to schedule time to review any questions, issues, or project-specific guidance you may need with your research. In this seminar, I will be covering the basics of the Python programming language to set the foundation that you will be using for the specific subject matter tools and libraries that will be covered in future seminars. Programming, or coding, has an unwarranted reputation for being difficult and only available to specialist computer scientists, when in reality is an indispensable tool for people of various technical abilities. Programming is simply the act of providing your computer with a series of commands to be executed. Why should you bother learning Python? Because if you are interested in anything from basic statistics for clinical trials to AI and bioinformatics research, Python allows you to complete your tasks very quickly with much more impressive results than you could do manually. Any kind of statistics can be accomplished with Python, from basic t-tests to highly specialized tasks. Compared to the R language, which is commonly touted as an easy way to perform statistics, Python is arguably simpler, with less frustrating roadblocks and more control over your variables. Additionally, you can very easily create impressive-looking publication-style visualizations for your data that can impress. There are also more specialized libraries for clinical trial-specific analyses, such as generating Kaplan-Meier curves and Cox proportional hazard models, and more. For those interested in medical image processing or machine learning and AI, Python is the go-to language for anyone in this space, with a vast cache of libraries that allow even beginners to do what they need. And for those of you that hate yourselves and want to do bioinformatics, Python provides you all the tools that you would need. Over the course of the future seminars, we will be reviewing some of these libraries in greater detail. So let's begin. The hardest part of starting to code for most beginners is setting up your computer ready with all the installations, editors, and environmental paths that are a prerequisite. This is typically what disillusions most beginners. And this is why we're going to skip this step, at least for now, and get started with the fun stuff that we all care about. To do this, I will show how to use Google Colab, which provides everything you will need for all these seminars and nearly anything you will want to do completely for free. To use Google Colab, either search Colab in Google or go to colab.google.com. Here, you will be asked to log in if you are not already, and the pop-up you will see will allow you to create a new notebook. Feel free to make a folder in your drive at this point to store your notebooks in a more organized manner. A notebook, or a Jupyter Notebook, as you see here, is typically referred to as an interactive console. And this is a code editor that allows you to write your commands in blocks called cells, like this one here. And you can execute each cell at the click of a button. And that's what this play button on the left is here. This makes running your code and visualizing any drawings you make extremely easy and is the tool of choice for statistics and visualization work, but can be used for nearly any project you are interested in. The first command you will want to know is the print function. Functions are another name for a command and are identified by having a pair of parentheses following the name. The aptly named print function simply prints what you provided to the output. So, for example, here, this will print out the phrase "Hello World" if I were to click on the Run button. Typically, commands in Python are executed sequentially, line by line. So if I were to press enter here, write another print statement, and execute this, you will see that the first line is executed, printing hello world, and then the second line is executed, and you see world. Let's quickly review the common data types inside Python. I'm going to create a new code block here to separate out these two ideas. So the first data type I want to discuss is what you've already seen, strings. So strings are identified by having a pair of quotes around them. And inside a string, everything is treated as text. So anytime you would want to have any type of text, you want to reach for a string. The next data type is an int or integer. And this just refers to any number. It could be 1, it could be 9, it could be 2000. The next data type is called the float. And float simply means a decimal number. If you want to have any type of decimal, you are using a float. And this can be any decimal number, including negative numbers. And that goes as well for integers. The next data type I want to cover is called Boolean, which is either true or false. Capital true or capital false. And these are going to be used for conditional statements, as you will see later on. The last data type that I want to cover are lists. These are simply, as the name implies, a list of any of the previous data types. It can either be the same data type or it can be a mix of various data types. Another thing I want to mention before we move on is comments. Comments are simply pieces of text that you want to use to add comments to your code that Python ignores. So you can add comments after a pound sign, and anything that follows the pound sign will not be executed as code. So for example, here I am commenting what each of these data types are. Values are stored in variables. Variables can be named anything you like, minding some basic rules, such as not starting with a number and not having spaces. The way you assign a variable is by writing a variable name, an equal sign, and the value you want stored inside that variable. Then moving forward, this variable name will always refer to that value that you assigned it until changed later. So if I were to run this, you can see that it is 5. Next, I want to show some various operations that you can use on these variables or values. The first one is going to be addition. So these first few you're going to be already familiar with. Addition, you can do a variable and add some other value to it. In this case, we'll do 4. And running it will give us 9. Next, we have subtraction. Then we also have multiplication. Using the star operator. And then we also have division with the /. The next few you might not be familiar with, but they are also very simple. First one is going to be something called floor division, and this is denoted by having 2 /. And what this does is it does your regular division and then simply drops everything after the decimal. So 1.25 becomes 1. The next one I want to cover is called modulus. And modulus is denoted by a %. And what it does is, in a similar way to how division works, instead of giving you the number, it gives you the remainder. So if we have 5 divided by 4, 4 goes into 5 one time with a remainder of 1. One thing to keep in mind with these operators is that just like in math, there is an order to these operations. For example, if you have 3 plus 4 times 5, it does not run from left to right. If you were to do left to right, you would get 3 plus 4, which is 7, times 5, which is 35. But if you run this, you realize that's not what you get, because the multiplication happens first, and you get 20, and then plus 3. Typically, the best practice is, just like in math class, to add parentheses to whatever you want to occur first, just so it is additionally clear. In this case, it would be the same answer, but if you want the addition to happen first, you can put a pair of parentheses around it, run it, and then get the answer that you were looking for. Since we are looking at some math operations at this point, I'm going to demonstrate several math functions that you have available to you. For example, you have the round function, where if you put in a number, say 3.14, and run this, you get the rounded version. If you were to change this to, say, something like 3.6, it will round up for you and go to 4. There are some other ones, such as ABS, which stands for absolute value. And if you remember a math class, absolute value simply gives you the positive version of any number you give it, like so. You also have the min, which stands for minimum, and it will give you the minimum of 2 values. Simple enough. And the opposite of that, you have max, and I think you can guess what this one does. Now, there are several more math functions that you can use. However, in order to do that, we're going to have to do our first import of a library. And you will get used to this as we get along to more advanced functions that we want to use. This function is called math. And the way you do that is you type import, then the name of your function. Typically, this is done at the top of your notebook. However, for simplicity here, we're just going to leave it here, as it applies to everything following this line. For example, if we want to take a square root, we would call the math library, and then to get a function inside of this library, we place a dot, and now it's looking at all of the functions you have available here. Square root, for example, is sqrt, and inside of this, if we say put 16 and then run it, we get the answer 4. Now I'm going to move this to a different cell, run this again, and run that again. There you go. There's many math functions here, and if you want to explore them inside Google Colab, if you type the library and then type dot, you will get a list of all of the libraries that you can use here. For example, we can do sine of math.py divided by 2, and we will get the answer. You may have noticed that when you don't have a print function in a notebook, you will get an output, but it will only be the output of the last line that you ran. This only works in notebooks, and if you were inside a regular Python file that we will discuss later on into these seminars, you will not have any output without the print statements. Moving on, I will cover a very important topic in Python, and that is if statements or conditionals. Conditionals are, for example, if you have a variable a, that's 22, b, that's 300. A conditional is a statement such as A, I'll print it, print A double equals B. A single equals in Python assigns a variable to a value. But if we want to check if something is equal to another, we use a double equal sign. So if I run this, you will see that we get false, which is a Boolean value, and it's false because A does not equal B. We have several other operations. So this is checking for equivalence. We also have A is less than B. A less than B. We can have A is less than or equal to B. And we have the opposites. And greater than or equal to B. And then the last one is A does not equal B. In Python, if you want to check if something is not equal to something else, you use the exclamation mark before the equal sign. So A is not equal to B. So of all of these, some of these will return true and some of these will return false. So if I go here, oops, close that up. If I go here and I add a print statement to each of these, since A is smaller than B, we expect to get false, true, true, false, false, true. False, true, true, false, false, true. Now this is useful because in Python and many other languages, conditionals are a key building block to building more complicated functionality. For example, we already have A and B here. If we wanted to print something only if A is less than B, we would use an if statement, which is written with the word if and then parentheses, and then you put a conditional inside these parentheses. For example, A is less than B. And we followed the if statements with a colon. Now in Python, every time you have a statement with a colon, the next line or everything you want to be encompassed by that statement will be indented. You can see here that this now is indented. So if I were to write print string A is less than B, and we were to run this, we would see the output A is less than B. However, if we were to change this to A is greater than B and run it, we would not get an output. Another thing to note is in Python, this white space, this indentation, is important. If you don't do it, you get an error. So we want to make sure that we have that. In if statements, you can have an else statement that follows it. For example, this would read, if A is greater than B, print A. Oh, we gotta change that. If A is less than B, print A is less than B. Else, print A is greater than or equal to B. And like I mentioned before, just because you set variables before does not mean you can't reset them later. So now if we make A be greater than B and we were to run this, the other condition will be fulfilled. Now I want to go over our first exercise called product and sum. The whole point of learning to program is to learn how to solve problems that we encounter. In order to get good at that, and in order to get comfortable using this programming language, we have to practice solving problems. And that's why I recommend that whenever we reach an exercise in these seminars, that you pause the video for 5, 10, 15 minutes and try to use the tools that you've gotten to try to solve these problems. And the practice is what gives you the improvements. You can sit and listen to all the seminars from beginning to end, and you will learn something. However, you will be cheating yourself if you don't try to solve these practice problems. Because if the first time you're actually trying to solve a problem is when it's a research problem or a problem you encounter in any other project that you're doing, then you will feel stuck and not sure how to proceed. These exercises will hopefully give you the opportunity to build your problem-solving skill set using Python. To get started, first you want to read the description. So given two integer numbers, write Python code to return their product only if the product is equal to or lower than 1000. Otherwise, return their sum. So with everything that we've learned so far, this should be possible to do. So if we go back to Colab, before we do so, the way you read the bottom part here is the top part given is going to be your input. So if you have number 1 and number 2, the expected output is down here. And we can see it's a string and it has the output over here. And it is the product because the product is less than 1000. On the right side we have 40 and 30, but the result is 70, which is the sum. Because the product, I believe 1200, is greater than 1000. So how do we do this in code? So if we go back over to Colab, let's make a new code block, and then number 1 was 20, number 2 was 30. So we want to check if the product is less than or equal to 1000. And as we just covered, this is an if statement. But before we get to the if statement, let's create a new variable, product. Let that be equal to number 1 times number 2. And the sum, which we will set equal to number 1 plus number 2. Now in our if statement down here, we want to know, is the product less than or equal to 1000? If that is the case, we want to print the result is, and we want to add the number at the end here, which is the product. Else, this means that the product is greater than 1000. We want to print the result is the sum. Now if I were to run this, you will see that we get an error. Here it says type error can only concatenate string, not int to string. And then above here, you basically see what's called the traceback, or where that error occurred. And this arrow is pointing to this statement. And what it's trying to tell us is that we're trying to add an int to a string, but we can only add strings to strings. There is two ways we can fix this, and I will cover both of these here. There is a function called string, And what it does is it converts any of the other data types, such as floats or integers, to strings. And we can do that with both of them here. And if we were to run this, we get the solution. And if we try the other input, if we go back, it was 40 and 30. So num1 equals 40, num2 equals 30. And we run this, we get the result is 70. Before we move on, I want to cover the other method to solving this problem. So here, to fix the issue of adding an int to a string, we converted our our ints to strings. However, there is another method to do this, and this is called using f-strings. F-strings are simply called that because the way you use it is you add an f before your string, and then in your string you can add curly braces and then add any variable you want that will be inserted there. In this case, we want to add the product, and if we add f to the string in the bottom, add the curly braces and add the sum, the result is the same. Both of these are valid options, and you can use either one comes more naturally to you. Next, I want to cover working with strings and indexing. So on the screen here, you will see the string Python. Strings are named so because they are, in essence, a string of characters. In this case, Python. And if we want to reference a single character or a subsection of a string called a substring, we have to use what is known as the index. It's basically a count where each of the characters have a specific position inside the string. And in Python, counting starts with 0. So if you want to get the first letter in a string, you index it with 0. So let's take a look at how this looks in code. So if we scroll to our bottom code here, if we set b equal to hello world, if we print b, and the way you index is with square brackets here, and we put our index here, we get the first letter. If we want to get the O, that would be, and you count 0, 1, 2, 3, 4. So O would be the fourth index. Great. You can also index backwards. If you do -1, you get the last character in the string, -2, second to last, and so on. This is useful because you can get sections as well. So let's say you want to get the first 4 indexes. You can do 0, 4. So the way Python works is that it gets everything up to but not including 4. As you may remember, 4 is O, but if we were to print this, you only get the first 4 letters, HELLO, but not the 4th index. That is important to remember. Another thing with this that you can do is shorthand. If you want to start from the beginning and go until the 4th character, like so, you don't have to specify 0, even though you can. You can simply say :4, and it goes from the beginning to the end. You can do this the other way around. You can do 4, and if you leave the after blank, it goes all the way to the end, like so. So if we go back, if we want to do 1 to 4, it drops the first letter and goes to the 4th letter. One more thing that I want you to know with indexing is, let's say we have 0 to 5, just so we can get the hello, but we want to get every other letter. You can add another colon, and typically the default value here is 1. So if I were to run this, you still get every letter. But if you want to get every other letter, you add a 2 here, and it skips every other letter. And you can add any number here. You can also add -1. And what -1 does, to do -1, you actually have to drop those 2 numbers. And what that does is it reverses your string. So let's take a look at our second exercise. Here, it wants us to write a Python code to remove characters from a string from 0 to n and return a new string. Okay, so if we look at our first example, our text gigum, our indexes 0, 1, 2, 3, and 4. And here you can see that it gives us, so it wants us to have 4 and on. Same thing here. Our text is howdy, our n is 1, our indexes are 0, 1. It wants us to give it 1 and on. Okay, so let's see how to do this in code. Again, I recommend trying this yourself first before watching the solution. So in the first case, coming back to Colab, we go to a new cell. We can start with the first text equals gigum, and our n was 4, and the expected output was the 4th index and on. And as we did before, this one's pretty basic. Text, we want to start with our nth and go to the ends. So if we print this, we go back here, that's what we expected. If we try this with howdy and n equals 1, howdy, n equals 1, we get howdy, as expected. The next 2 topics I'll be covering are going to be very important and go hand in hand. Here we're going to learn about lists. As I mentioned before, lists are simply a list of the other data types that we've seen. Here we have a list of strings. The strings history, physical, assessment, and plan. To get the length of a list, you use the len length function, in this case 4. Indexing lists is very similar to strings. You start counting with 0 and you count up, and to index your string to index your list, just like the string, you use the square bracket. In this case, the 0th or the first item in your list is history. You can also take sublists using the same syntax as strings with the colon. For example, you go from the first index, physical, up to but not including the 3rd index. The 3rd index is plan, but you don't include that, you get the one before it. So you get physical and assessment. Just like strings, you can reverse lists using the square brackets, 2 colons, and a -1. For loops go hand in hand with lists. And these are another very important topic that's important to learn before we move on to more complicated tasks. A for loop lets you loop over a list. In this case, we have the same list as before. What we can do is we can say for x in list, and don't forget the colons here and the white space at the beginning. what you can do is you can loop over every value in that list. So for example here, if we print x, what will happen is whatever's inside your for loop will happen multiple times, once per each item in your list, and x will be set to the item that it's currently on. So first, x is history, so it prints history. Then it goes to the next item, which is physical, so it prints physical. And then it prints assessment, and then it prints plan, in order. You can have conditionals inside your for loops. So for example, if you are looping through each item, you can write an if statement, such as if x equals assessment, print x. So this only prints x if x is assessment, and down here we only get assessment. But the loop is still going through each one. It's checking, is this equal to assessment? But it's going to be false for every single one except this one, so we don't see an output. Another thing that's commonly seen in for loops is the use of the range function. What range does is it gives you all the values from 0 up to the number that you give it. In this case, for x in range 10, we are printing all the numbers from 0 up to, but not including 10. So we get 0 all the way through 9. And these are 10 numbers. The reason why this is useful is if we go back to our previous example of my list with the history, physical assessment, and plan, we can do the same thing we did before, but in a slightly different way. Instead of saying for x in my list, we can say for x in the range of the length of my list. So in this case, the length of my list is 4, which means we will be, the input to our range is going to be 4. So the number's 0 up to 4, but not including 4. What this does is it actually gives us all of the indexes to this list. So x here can be seen as the index. So if we do my list square brackets x and we print this, we will print out history, physical, assessment, and plan, just like before, but this time using the index 0, 1, 2, and 3. This lets us move on to our third exercise, printing characters at even indices. As before, I recommend trying this out by yourself, pausing the video, and then coming back after you give it a fair try yourself. So what it wants us to do is write a Python code to accept a string from the user and display characters present at an even index number. For example, str equals Texas A&M, so your code should display TXSAM, because remember, we start with 0. 0 is an even number. So the original string is Texas A&M, printing only even index characters. Alright, so if we go back to our collab, create a new code block, and set our string equal to Texas A&M, we want to get only even indices. So how do we do this? There's two ways we can do this. The first way is the method that I already showed you, which is we can print our string and we can go from the beginning to the end, but put a 2 here so it skips every other value. And while this accomplishes what it says, we can see that it's not in the same format that we see here, TXSAM, each on its own line. This is because they are doing this slightly differently. what they are doing is they are using a loop. So let's do it that way. As you can see, there's multiple ways to solve each of these exercises. So in this case, we'll use a for loop. So we'll say for I, or let's do for character in string. And if we were to just print character, just to see what we're doing, we can see that we're printing each of the characters in the string, but we don't have a way of determining what is even and what is not. However, we can come into the string here and we can do what we did before. We can skip every other character. And there we go. There is one other way that you can solve this that I want to go over. So we can do the other method, which is we can put a range around the length of the string, which functions as a list. And here, this was no longer the character. This is now the index. And we index the string. And where we get this again. Here, we can use the operator that we learned before, modulus, to determine if the index is even or odd. And the way you use modulus for this is if you have your index and you mod 2, so if you divide by 2, you're getting the remainder. The remainder, when you divide by 2, is 0. You have an even number. And make sure you indent, because you added a conditional. And you run this, and there you go. There's 3 different ways to solve that exercise. Moving on, we are going to write a Python code to iterate the first 10 numbers. And in each iteration, print the sum of the current and the previous number. Okay? So we print the current number, the previous number, and then the sum all the way up to 9 here. And scroll down, add another code block. We want to go through the first 10 numbers. But first, we want to keep track of the previous number. So I'll make a variable, set it equal to 0. And then we're going to go for I in range 10, colon. We want to add them together. So we want to print, we'll use an F string, previous number, current number, and sum. So the first one is going to be previous. The current one is going to be I, and the sum is going to be previous plus I. So then here what we want to do is we want to set previous equals to I. So what's going to happen is for every loop, in the first loop, previous is going to be 0 and I is going to be 0. And the loop after that, I is going to go up to 1. Previous will still be 0. I will be 1. You add them together and you get 1. And then previous will be set equal to 1. And then I will go up to 2. So if we run this, 0, 0. So all the sum is 0, 1, 3, 5, 7. Just odd numbers all the way up. And that's what we get. Simple enough. Now we want to write a code to return true if the list's first and last numbers are the same. If the numbers are different, return false. Okay. So given lists, okay. So the first number is 10, 20, 30, 40, 10. 70, okay. Let's create a new block here. Whoops. Equals 10, 20, 30, 40, 10. L1 and L2. And then 75, 65, 35. 75, 30. 75, 65, 35, 75, 30. Okay. So for the first one here, what I'm going to do is I am going to package this in a custom function. And this is pretty simple. The way you do this, to create a function, you start off with the keyword def, as in define, and then you give it a name, just like you would give any variable name. Equal first and last. And then you add parentheses. Here you want to name, I'm going to say, my list. So what this means is that the function equal first and last takes in one input, which is my list. And then inside here, what I want to do is check if the first and last are equal. So if my list, the first index, equals my list, the last index. If that's true, return true. Else, return false. And then the way you would use this function is by calling it like any other function. So print equal first and last, and we give it L1. And it gives us true because that the first and the last numbers are the same. And if we do L2, it's false. So for functions, you don't use print because print simply just prints something out. What you want to use is return. Now what return does is it gives the value of whatever is returning as the function. So for example, we can set the return value as a variable and then work with the variable like so. Another interesting fact about return is that whenever a return statement is hit, the function ends. So one thing you can do with this is you actually don't need this else statements, because if the first and the last numbers in your list are equal, this returns true and the program ends. If this isn't true, it hits false. In this next exercise, we are going to write code to display numbers from a list divisible by 5. So if our list is 10, 20, 33, 46, 55, we only want to list 10, 20, 55. Okay? So my list is 10, 20, 33, 46, 55. We only want to list those that are divisible by 5. How do you check if something is divisible? So first we want to loop through my list. If we were to print I, okay. So this is where modulus comes into effect again. So modulus it's, if you remember, you are dividing by a number, but instead of getting the result of the division, what you care about is what the remainder is. So if you were to do modulus 5, you're dividing by 5 and returning the remainder. If a number is divisible by another number, you wouldn't have any remainders, meaning your resulting division, so if we replace this with, or actually, I'll add down here, better yet, I'll add to the side, I divided by 5, we can see whenever a number is divisible and you don't have any decimals, the remainder is 0. But whenever you do have decimals, the remainder is not 0. So this is one very useful application of modulus. So here in this problem, it asked us to only print the numbers if it is divisible by 5. So we'd say if I modulus 5 equals 0, print I. And that's what we get. And here we want to write a Python code to find out how often the substring Emma appears in the given string. And our given string is Emma is a good developer. Emma is a writer. So let's go back here. Code. Emma is a good developer. Emma is a good writer. So how would we do this? There are two methods we're going to do this, and both of these methods are string methods. We have not covered these yet, so this is going to be a good opportunity to expand on your string knowledge. So the first one is the simplest. Strings have a function called count, and it does what you think it does. It counts the number of times a substring is inside of it, and that already gives us the answer. However, that one is not as fun as this other one. So another, I'm just going to leave that. Another way to do this is with another string function. What we can do here is, first, let's create a variable counts that we're going to use to count how many. Next, we are going to use another string function called split. What split lets us do is cut a string into a list of strings using a target string. So in this case, I want to split on all the spaces. And if I were to print this here, you can see that everywhere there was a space in the string, it cut the string into a list. And now what we can do, or we're gonna set this as a variable, split string. And let's keep it consistent. And we can loop over this string. So for s in split string, if I were to print s, you can see we're looping over each of those substrings in the list. Here we can check if s equals Emma, count equals count plus 1. So what this does is it takes the count value and adds 1 to it and sets it equal to count. So it just goes up by 1. Another way of writing this, as you'll see commonly, is this can be replaced with plus equals 1. What plus equals does is it takes the count, like you just saw, adds 1 to it, and sets it as the value of count again. And then if we go here and at the end, we type print count, we will get 2. So 2 different ways of doing it. Here, this is a different kind of exercise. We want to print the following pattern. We can see we have half a triangle, or I guess it's still a triangle. We print 1 once, print 2 twice, 3 thrice, and so on. So in order to do this, we are going to need to use for loops. So let's say for first number in range 5, because we're going 1, 2, 3, 4, 5. However, if we were to just print these, we're starting with 0. That's not what we want. So two things we can do. Either we can add 1 here, just shift everything up, or we can come into range and give a beginning number and increase this to 6. So same thing. I'm going to keep the first option just because that's how we've been using it so far. So now however, we were trying to draw a triangle here. The 1 is correct because we just want to print that once. However, we want to print 2 twice. So what we need is another for loop. And how this is going to work is here we're going to add another for loop. So for second number in range, and here we want to run we want to print the first number 1 once. So here we're going to say first number plus 1, because remember it's 0 at first. And then when it goes up to 2, we're going to run it twice. So we want this to be 2. So for loop, so we put the colon, and then we indent this. However, you see that even though we get what we want, it doesn't look like what we want. We have the right number of 5s and 4s and 3s and 2s and 1s, but that's because the print function always writes to a new line. So what we can do here is instead we'll create a string. We'll set it equal to an empty string at first, or actually we're going to put it inside here, because for every number we want to have a new line. And instead of printing here, what we want to do is we want to add this number to string. But if you remember one of the first exercises we did, we can't add numbers to strings, so we have to convert this number to a string with the string function. And then at the end of the first loop, we want to print that string. There we go. And to make it look a little bit more like what we see here, you can see there's a space in between each one. So what we can do here is we can just add a space. And there it is. Moving on. Here, we want to check if the given number is a palindrome. If you don't know what a palindrome is, it's a number that is the same after reversing it. For example, 545 is a palindrome number because 545 is 545 reversed. So if we have 121, we should say yes. And if it's not, we should say no. I'm going to simplify this a bit. If it's a palindrome, we just want to print true. And if it's not, I'm going to print false. All right. And for this one, I'm going to write it in a function just for more practice. Okay, so we're going to write a function is palindrome, and we're going to take a number. Okay, so how do we check if the number is that number in reverse? what we're going to do is, to keep it simple, and as I've shown here above, you can convert a number to a string. So let's say we print this number, and then we print also the string version of that number, just to compare. And if you noticed, if I run this, nothing happens, because when you have a function, you need to actually call the function, let's say with 1, 2, 1. There we go. So you can see they look the same, even though the one on the left is an int and the one on the right is a string. And if you remember with our working to string section, what we can do is, let's say, let's come here, str number. So the string version of our number is str num. Can remove this. And if you remember our indexing rules, we can actually reverse a string like this using double colon -1. If we run this, it's still 1, 2, 1. I mean, there's a palindrome, so we expect it. Here we can set reversed str equals to this reverse str. And we can say if the str num is double equals to reversed str, return true. Otherwise, we return false. And remember, when you're in a function and you are using return statements, you don't need to use else, although you could. But return ends the function. So it's typically standard to do it like this, because it will only get to return false if this return true doesn't happen. So if we run this, now we get true. If we put in a number that's not a palindrome, say 1, 2, 3, we get false. Here we are going to be given two lists of numbers, and we want to create a new list such that the latest list should contain odd numbers from the first list and even numbers from the second list. Okay. So in the first one, we have 10, 20, 25, 30, 35. Okay. List 1 equals 10, 20, 25, 30, 35. And list 2 is 40, 45, 60, 75, 90. And we want to get the odd numbers from the first list and even numbers from the second list. Okay? And here I'm going to use a for loop. I'm going to go by the index. So let's say for I in range length, and I'll just pick one of them because they're the same length, list 1. I'm going to just print it out so we can see what we're working with. List 1, I, list 2, index I. Okay, so now we want to get the odd numbers from the first list. So it's going to be 25, 35, and then the even numbers from this list. So what we need is we need a final list. So final list, we're going to make that an empty list. And if list 1 I is even, if you remember how we check if it's even, we modulus by 2, 0. If it's even, we want to add to the list, and the way you add to a list is using the append function of the list. So it's your list dot append, and this adds to the end of your list, or to the right side of your list. And we want to add that number, list 1 I. But also we want to check if list 2, oh, actually, well, for the first list, we want to add the odd numbers, I'm sorry. So a number is odd if modulus 2 equals 1. Next, we want to check if the items in list 2 are even, which is mod 2 equals 0. And then we also do the same thing, and we append list 2 I. And then at the end, we print the final list. Although our numbers are in a different order, you can see that it's the same numbers. If you want it to look exactly the same, theirs is sorted. So what we can do is we can sort ours by adding the sorted function here. Oops, missed that last parentheses, and there it is. In this one, we want to, given an integer number, 7536, the output shall be 6357 with a space separating the digits. Okay, 7536. Okay, so our number is 7536. We want to reverse it and have spaces in between. So how do we want to do that? Well, we already know how to reverse a string. And you reverse the string. Well, first we have to make it a string. And we can reverse the string by the double colon -1. So let's set that reversed str. Okay. Now what we want to do is we just want to add a space in between. There's two ways we can do this. The first way is using a for loop. We can now loop car in reversed string. We can create an empty string here like we did before. And we can add the character to our string plus a space. And then at the end, print s. Another way to do this is using another string function called join. So what join does is if we have our reversed string here, join adds a string in between each character of a string or between each item in a list. So what we can do is we can come here and add what we want in between each one, which is a space. Do dot join and give it the string we want to add that space to. And we get the same output. Take your pick. All right, moving on to our last exercise. This one is a little bit more involved, not by much though. What we want to do is calculate income tax for any given income by adhering to the rules set below. So for the first 10,000, our interest rate is 0. For the 10,000 after that, it's 10%, and anything above that is 20%. For example, suppose the income is 45,000. The income tax payable is 10,000 times 0. 10,000 times 10 plus 25,000 plus 20. Okay? And here we get income tax of 6,000. All right, so we're going to do it for the 45,000 sample case. Here, I'm going to create a function, and I'm going to call it calculate income tax, and we're going to take the income. So how do we want to do this? We want, let's say our income is, here we're going to call calculate income tax, and we're going to give the income 45,000. Okay. So what we want to do is we want to ignore the first 10,000. So what we want to do is, I want to say income minus equals 10,000. Okay, so what this does is it subtracts 10,000 because we're not going to calculate anything on that. And here we want to check if income is less than or equal to 0, return 0. Because if you have 10,000 or less, you're not going to pay an income tax. Next, what we want to do is we want to begin calculating. So our tax is going to be equal to or actually we need to say if now the income is less than or equal to 10,000 again. That means it was between 10,000 and 20,000. Here we only pay a tax of 10%. So our tax is going to be the income times 0.1. And finally, we're going to check if income is greater than 10,000. So actually we don't need another sentence, if statement, because if neither of these if statements were true, then we move on. Otherwise it would have returned and it would have canceled the function or ended the function early. So now what we want to do is we want to return. At this point, we know that we have more than 10,000 remaining. The first 10,000 should be charged at 10%. So we just put 10,000 times 0.1 plus your income minus 10,000 times 0.2. So it's going to tax the first 10,000. Well, first we subtract the 10,000 initially. So this is the second 10,000. We tax it at 0.1, and then we add, take another 10,000 away, and then take 0.2% of that. And this combined is going to be your total income tax. And we're missing the colon there. Run it again. 6,000. That's what we expected. And this is the last exercise. I hope that you were able to tackle some of these by yourselves, and I hope that my explanations and demonstrations were helpful. Moving on to the next seminar, we are going to begin importing libraries that have been written by other people to enable other functions such as visualizations and statistics. See y'all next time.